Okay. Yeah, I'm Paul. We're doing Leetcode, must know interview questions. Today's challenge, integer to Roman. It's rated medium. The last one we did was Roman to integer, which was rated as easy. Roman to integer is easy because you can just parse a Roman numeral from beginning to end and convert it to an integer. But an integer is not that easy. You can't just read it from beginning to end. Let's say the first digit is a 3, but what is that? Is it just a 3? Is it 30 something? Is it 300 something? Is it 3,000 something? Actually, let's check the constraints here. Okay, yeah. So the number is going to be between 1 and 3999. I don't think Roman numerals go higher than that because the largest symbol is M, and the rule is you can't have 4 of the same symbol in a row. So we'll get a number between 1 and 3999. Okay, so one way to start on this is to check and see if the number is greater than or equal to 1,000. So do an integer division by 1,000, and that will tell us how many m's we need to put at the beginning. So that's a good start. After that, it gets a little bit tougher because the next symbol is D, which is 500. So after you put the m's, after you mod the number by 1,000, whatever's left, is it greater than or equal to 500? Well, we could just put a D if the number is greater than or equal to 500, but there's an exception there if the number is greater than or equal to 900, because the D won't work. For 900, we've got to put CM. So we can check if it's greater than or equal to 500, but we've also got to check against 900. And this applies all the way down. That is, you can keep, divvying and modding the number, but we would next compare to 100, but we've also got to compare to 400. We've got to compare 50, 90, 10, 40, 5, 9, 1, 4 because of these exceptions in the way certain numbers are handled. No more than 3 of the same symbol in a row. But I think with some pre-processing on this, that we can actually come up with a pretty nice solution. Take a quick look at the topics. Topics, hash table math string. Okay. I don't think we want to do a hash table on this one. I mean, you could do a hash table, but then I think you would have to, count the number of digits and keep track of where you are. I mean, there's a number of ways to do this with elaborate if-else structures. The hash table, yeah, I mean, the hash table, you're going to need an if-else structure. I guess you could do a recursive solution to it. But anyway, let's code up our solution. Okay, as I said, we're going to do some pre-processing here. This is it's almost like cheating, but it's not. We're just going to write out all the possible numbers and keep them and store them in arrays, and then just index them as needed. So we have the thousands. We've written out all the hundreds, including the exceptions. Yeah, 2 exceptions. So 400, 900 are exceptions. We've written out all the tens, and we've written out all of the ones, the single digits. All right. What is the input here? Num. All right, so let's do this. We can get the thousands. The thousands were never a problem anyway, but the thousands are going to equal m at num div 1,000. And actually, let's do this. Then the hundreds would be, we're going to use the C array. The C array, we've got num mod 1,000, whatever's left from thousands, and we should put that in parentheses. And then div 100. Okay, that looks good. One more, I'm going to copy that. Well, I'll copy both of them. Hundreds, tens would be the X array. That is going to be num mod 100 div by 10, and the ones, whoops, what happened? The ones would be the I array. I array num mod 10. That's just the last digit. Take that off, and I don't really need parentheses either. All right. This returns a string, so we're going to return thousands plus hundreds plus tens plus ones. All right. Let's try it. I can't see the result. Hold up here. Oh, okay. So the basic case is accepted. Submit. Well, okay. It wasn't like a super efficient solution. It looks like most people on the, well, let me see this first. Where's the runtime? Runtime, memory. Oh, there's the memory. Yeah. You know, last time I was tempted to blame the use of hash table for the Roman to int percentages, but this is even worse, and I didn't use the hash table. But anyway, it still goes in the scorebook as a win, even though most people seem to be better in terms of time and memory. But I bet you their solution is uglier than this. So anyway, into Roman, lots of different ways to do it, but I like this one. So that's it. Feel free to like, subscribe, and see you next time.